notes, so make sure you have these out and something to write with. Now, if the video is going too fast, make sure you pause it so you guys can write everything down on your piece of paper, okay? So pause the video anytime during the notes so you can jot them down. So looking at the first one, we have 4 to the 5th times 4 to the 2nd, or 4 squared. We are going to expand that and then write our simplified answer after the expansion. So looking at 4 to the 5th and 4 to the 2nd, they both have the same base of 4. Right? So just recapping on vocab, those two numbers are the bases. And then the 5 and the 2, those are exponents. So we're going to expand. So let's do that over here. So we're going to expand 4 to the 5th, which means we're going to multiply 4 5 times. So I'm just writing my 5 4s. 4 to the 2nd means I need to multiply 2 4s. Now, you should notice that there is a multiplication sign in the center of those two numbers. So we're multiplying them together, okay? Product means to multiply. So I'm going to put my multiplication symbol there, and then 4 to the 2nd, I'm multiplying 2 more 4s together. So if I look at my expansion, I have a total of 1, 2, 3, 4, 5, 6, 7. 7 4s. So I can rewrite the exponential expression as 4 to the power of 7. Okay, let's do another one. So we have 9 to the 1st times 9 to the 3rd. So again, we're multiplying two numbers together, and both numbers have the same base of 9, and then we have an exponent of 1 and 3. So we are going to expand the first one. 9 to the 1st means we have 1 9. And then times 9 to the 3rd. 9 to the 3rd means I have 3 9s. So 9 times 9 times 9. Now looking at this, I'm multiplying a total of 4 9s. So I can rewrite this as 9 to the 4th. Okay, next one, we have negative 2 to the 2nd times negative 2 to the 3rd. So I should notice that I have the same bases of negative 2. So the first one is negative 2 to the 2nd, means I need to multiply negative 2 2 times, times negative 2 to the 3rd. So I need to multiply negative 2 3 times. So I have a total of 1, 2, 3, 4, 5. 5 negative 2s. So negative 2 to the 5th power. So you may have noticed a pattern here on what we're actually doing. We don't want to expand every single time because that's going to take a while to do every problem like that. So let's look at this closely. So I should notice that my bases are 4, which if I look at my answer, my base is still 4. My exponent is 7. So really what we're doing is we're adding 5 and 2 together to get 7. Looking over here on the next one, we had 9 to the 4th as a solution. So 9 was the base. Now my exponents was 3 and 1. So if you add 3 plus 1, you get 4. The next one was negative 2 to the 5th. So we kept the base the same, and then we can just add 3 plus 2. So for the product rule, you keep the base the same, and we're going to add the exponents. So let's move down over here. Now looking at this problem, the base is the same. You have to make sure it's the same. So x and x. We're using multiplication. You can see it right there. So we know we're going to utilize the product rule. So what we're going to do is we're going to keep the base the same, which is x, and we're going to add the two exponents together. 2 plus -3 is -1. So x to the negative first power. Now I'm leaving some space because we just talked about the other day that we cannot leave a negative exponent. So if it's x to the negative first, that's currently in the numerator. So we have to move it down below to make it a +1. And then we need to add a 1 up top. Now we don't need the +1 as an exponent with x because x to the first power is just x. So we'll just write this as 1 over x. Okay, next one. We're going to look at this one. So our bases are the same. So if the bases are the same, we can then add the exponents. -3 plus 2, similar to the last one, is -1. So 11 to the negative first power. So we have 11 to the negative first power. Now, I cannot have a negative exponent, so I'm going to move it into the denominator, turn it positive, and 1 over 11 to the first, which is the same thing as 1 over 11. Okay, next one, we have a base of -1, and we're going to add those two exponents together. So -2 plus a -3 is -5. So we have -1 as the base, and then -2 plus -3 is -5. So -1 to the -5th power. So -1 to the -5th. Again, we cannot have negative exponents, so we're going to move -1 to the denominator, and it turns to a +5. Now the base stays the same, so the -1 does not change to a positive because it's a base. And then put a 1 up top. And then we are good with that. Now, I mean, we actually could simplify this further, and we can multiply -1 5 times, which would just be a -1. So technically, -1 times -1 times -1 times -1 times -1. If you pay attention to the signs, you're going to get a -1. And 1 over -1 is just -1. Okay, but I will accept if you guys leave that one as a fraction, 1 over -1 to the 5th. Okay, let's go to the last one here. We have a base right here. They're the same, y. So since the bases are the same, we can use the product rule by keeping the base and adding the exponent. So we need to add 44 and 33, which is 77. So y to the 77th power. And that's it. We can't simplify that any further. Okay, I want you guys to flip over to the back side of the notes. You have 9 problems up top, and then number 10 is to create your own. Now, what I want you to do first is just to focus on 1 through 9. Okay, so you'll solve 1 through 6, and then you need to figure out what goes in the box to make the statement true. So right now, I would like you guys to pause the video and complete problems 1 through 9. When you are done completing problems 1 through 9, I'd like you to unpause the video and then watch it to see if your answers are correct. And then if you guys are struggling still, make sure you come and see me. So go ahead at this time, pause the video, and complete steps 1 through 9. Okay, now that you are back and you completed problems 1 through 9, I would like you to check your answers, okay, and make sure they are correct. So, starting with number 1, we have 5 and 5. They have the same base, okay? So, if the two numbers have the same bases, which it's 5, you can then add their exponents. 4 plus 3 is 7. 5 to the 7th, you can leave it as is. Okay, next one. Again, same basis of -8. Add the exponents. 4 plus 2 is 6. There's your final answer. -8 to the power of 6. Okay, this one. We are going to keep the base the same, which is z. And we are going to add -4 plus 3 is -1. Now, that needs to go into the denominator, so 1 over z to the first, or just z. Number 4, we keep the base the same, which is -3. We add the exponents. -5 plus -3 is -8. We cannot have a negative exponent, so move it into the denominator. So 1 over -3 to the positive 8 power. Okay, next one we have 99 to the first times 99 to the third. Keep the base the same, which is 99. Add 3 plus 1 is 4. 99 to the fourth. Okay, next one now we have 3, but they all have the same base of 8. Now we're going to add the exponents. So let's start with -4 plus 7. So -4 plus 7 is really like you're taking away 4 from 7. So that gives me 3. And then add the 2. 3 plus 2 is 5. And we can leave that as is. So I'm adding -4 plus 7 plus 2. Okay, next one, we have number 7. So we have the answer, and we're missing that second number. So I know that the base has to be the same, so it has to be 5. Now, if you remember the product rule, we add our exponents. So we need to look at 4 and think about 4 plus what would give me 10. Or take 10 and subtract 4, and you get 6. So 5 to the power of 6. Okay, next one. Okay, this one's a good one because we have a negative. So we're going to keep the base the same, which is 7. So we need to think we have a -4. So -4 plus what would give me 10? Well, if you think of -4 as taking away 4, what number, if you take away 4, would give you 10? Well, 14, right? 14 plus a -4 is 10. 14 minus 4 is 10. So that one was 7 to the 14th. Okay, this one, what I noticed right away, that's in the denominator. So if you think about putting this back up in the numerator. So before it went in the denominator, it had been a -2, right? Because if I put this back up, I would get r to the -2nd power. So what I want you to think is, if I have a 4, what would I need to add to 4 to get to -2? Well, I would have to add a negative number. So if I have 4, I need to take away more than what I have to get down to -2. This is -6. 4 plus a -6 is a -2, but then it moved down into the denominator, and that's why it's r squared. That one was a tough one. Okay, so if you did well on problems 1 through 9, you're then going to move on to number 10. I would like you to create your own 2 product rule questions and then also solve them and write the answers. If you struggled with 1 through 9 and you got multiple incorrect, I would like you to see me at this time.